Hi there, my name is Sarah and we're going to be going over end behavior algebraically and graphically for our Algebra 2 interim that is happening tomorrow. So we're going to start off with two graphs. Okay, so this is graph 1 and this is graph 2. Okay, we're going to label our x and y axis. So this is our y axis, this is x. This is y and this is x. So let's say I'm going to write two examples. There's going to be one slight difference between them. So f of x is equal to 9x squared plus 18x minus 315. And this one over here is going to say f of x is equal to negative 9x squared plus 18x minus 315. Sorry. Hello. Minus 315. So the main difference here is that one of the leading coefficient here, so that the leading coefficient in these two examples is 9x squared and negative 9x squared. So the main difference is that one of them is negative and the other one is positive. However, what's another thing that we notice? The degree that it's raised to is 2, and 2 is an even number, meaning that the shape of this graph is going to end up looking like a parabola because it's a quadratic basically. So when it's going to be a parabola and it's going to be positive, it's going to look something like this. So like this. Sorry for my bad drawing, guys. So since it's even and it's positive, the parabola is going to open upwards. So, but now let's say since it's negative on this other example, instead the parabola is going to go downwards. Downwards like this. So what's the end behavior? Well, the end behavior in this case, well, before that actually, let's label something here. We know that as it's going this way, right? As the x-axis is moving to the right, then it's heading in a positive direction. So here, it's positive infinity. As you go upwards, this is also positive infinity. However, if you go to the left, it's negative infinity, and as you go down, it's negative infinity. And that applies for all of these. So now how do we determine our end behavior? Well, we have to look at both sides. So let's focus on this side first. As x is approaching positive infinity, because we see that it's inclining more, like it's moving more to the moving more to the positive infinity side, and it's going upwards, meaning that in this area, as x approaches positive infinity, f of x or y, same thing, is also going to approach positive infinity. But now let's look at this side. As x is approaching negative infinity, y is approaching positive infinity. So what's our next end behavior going to be? Well, it's going to be that as x approaches negative infinity, y is going to approach positive infinity. And so what we see here is that both sides are heading in the same direction. You see how they're both going up because it's a parabola. So they're both going to go up in the same direction. The same rules apply here, except now it's a negative. So here, as x is approaching positive infinity, this time it's going downwards, meaning y, or f of x, is actually going to the negative infinity. However, now on the other side, as x approaches negative infinity, this way, it's actually going down. So y is going to approach negative infinity. And as I said previously, we can see here the pattern that they're heading in the same direction. So they're both going down to negative infinity. So that was for that portion. Now let's talk about when the degree of the leading coefficient is an odd number. and it's no longer even. It's going to be slightly different, but I'm sure you guys will understand. So, we're going to draw two graphs again. Here, one here. Sorry guys, it's kind of messy. Okay, let me make that bigger. Okay, so let's see graph 1. So it's gonna be f of x is equal to, let's say, 4x cubed plus 16x minus 45, I guess. F of x here is now going to be negative 4x cubed plus 16x minus 45. For now, what we want to focus on is mainly just these terms, our leading terms. So, what do we notice this time? The degree is odd, and it's a negative. This one is a positive. So this one is positive, and this one is negative, and these are odd degrees. So it's no longer gonna look like a parabola. Instead, it's gonna look a bit different. So I'm gonna show you. So when it's positive, the graph is gonna look something like this. If you look at it from like a distance, like on a calculator. So it's gonna look something like this, right? It's gonna squiggle right here. There's like a little squiggle. And then here on the other one, since it's negative, it's gonna go like this. So what we see here now is that they're no longer going in the same direction like a parabola. Instead, they're going in opposite directions. So I forgot to label it y, x. Okay, and just as a reminder, this is positive infinity, negative infinity, negative infinity, positive infinity. Okay, so what's our new end behavior going to be? Well, let's look at it. As x over here is approaching positive infinity, it's also going upwards to also positive infinity. So as x approaches positive infinity, y is going to approach positive infinity. But now on this side, as x is approaching negative infinity, it's also going to go down and reach negative infinity. And that would be your end behavior for this one. Now for this one, we can see that as x is approaching positive infinity, it's going to go down to negative infinity. So your end behavior would be as x approaches positive infinity, y is going to approach negative infinity. And for this other side, as x approaches negative infinity, y is going to approach positive infinity. So that would be your end behavior for there. And it's going to look a little bit different just depending, like when you actually are trying to graph it, it's going to look a bit different, but when you use your calculator and you press on zoom fit, it should look like this according